Hello everybody. We're recording a quick video just because not all of the classes got to the same point before we stopped last week, so I wanted to put this topic that was on the tail end for some of us because I'm not sure that everyone got there. And if you maybe tried out the warm-up and you noticed that you weren't sure entirely how to solve these, then maybe it's a good time to go back and look over these notes from last time. So hopefully this will be quick. But I want to discuss the idea of imaginary numbers. Imaginary numbers show up when we encounter some problems that shouldn't be solvable otherwise. For instance, look at x squared plus 4 here. If we were trying to solve this, we would begin by subtracting 4 from both sides. And this leaves us with the equation x squared equals negative 4. Now, at this point, we should take the square root of both sides. And then this would lead us to x equals plus or minus the square root of negative 4. So why is this a problem? Well, we know that the square root from last time is asking us what number times itself would multiply to create this value of negative 4. But this introduces a problem for us. Because if we're talking about 4's here, we might want to think that the answer is 2. And we could definitely do 2 times 2, but we would end up with positive 4. We want negative 4. So naturally, the next choice you might make is to multiply negative 2 times itself. But negative 2 times negative 2 also equals positive 4. And so it turns out that no matter how we mess with our signs, if we're multiplying the same value with itself, like our square root is asking, we can't make a negative 4 here. And because of this, because this problem was unsolvable, mathematicians decided to invent a number. They said, let's pretend that there was some number that when you multiply with itself, it would create negative 1. And they called this number I. So I squared is negative 1, showing you that it multiplies with itself to make negative 1. But I, as we're going to use it, is going to be representing the square root of negative 1, right? It's before we multiplied it with itself. So anytime we see a square root of negative 1, we can now use I to represent that. And that should make some problems that were unsolvable, like this x equals plus or minus the square root of negative 4, solvable suddenly. Whenever I see a problem like this, what I'm going to do is I'm going to go ahead and filter these out. I'm going to split this negative 4 into a negative 1. Excuse me, I said a negative 1, there we go, times a positive 4. See, all I did was slip the negative outside into this negative 1 part. And now we have easy names for both of these because we know that the square root of negative 1 is what we are calling I. And of course the square root of 4 is just 2. Right, so once we simplify those and rename them, then we can put all of our pieces together. Put your natural number before your I, just like when you do with x's, and we get a final simplified version of x equals plus or minus 2I. The process that we're going to go through is really similar to what we were doing when we were just simplifying regular positive square roots. But now we'll have an extra component to pull out, which is going to be that negative 1 that will turn into an I. Okay? It might be helpful to have our list of primes set up on the side. So remember, 1 squared is 1. We don't really care about 1. But 2 squared is 4. 3 squared is 9. 4 squared is 16, and so on. If you have this list handy, you will always know which values you're trying to pull out of your square roots. I apologize that my phone's going crazy right now. Okay, so we want to simplify the square root of negative 32. Well, the first thing that I notice is that I can pull out a square root of negative 1 here. This could be the square root of negative 1 can come out of this. That takes care of the negative. And then I need to break 32 up into some perfect square here. Well, 16 is the biggest perfect square that goes into 32. So we're going to split that 32 into square root of 16 times the square root of 2. And now you'll see these three pieces, if we were to multiply them together, would take us back to negative 32. But because we've got two pieces that we can now simplify, we're going to get a prettier answer. We know that the square root of negative 1 is I. We know that the square root of 16 is 4. And we can't really do much with the square root of 2, even though we tried. So it's going to still be hanging out at the end. The order that we should list these in is natural number, followed by I, followed by your radical. This is equal to 4I square root of 2. Okay, same idea is going to happen here in our second example. the square root of negative 192. We can split this 192, the negative 192, into 3 parts. One of them is going to be the negative 1, so pull that square root out. Then your calculator should tell you that 64 is the biggest value that goes into this. 64 times 3 makes 192. So there's our negative 192 there. Once again, we now call this I. The square root of 64 is going to be 8. And then our ugly piece that we can't really do much about is the square root of 3 here. You won't always have an ugly piece left over. You won't always have a nice piece that you can pull out of it, but if you have a negative inside your square root, you will know that you should pull at least an I out. So this becomes 8I square root of 3. At this point, if you're playing along, I would like you to try out try out the square root of negative 80 for yourself. Give it a shot, see if you can end up, if you get stuck anywhere, and if you get an answer, you can fast forward through me if you want, but I'm going to work through it after just a couple of seconds to let you guys check your work against mine. Go ahead and pause me now. It's okay. Yeah, hit the button over here. Is it over here? Hit pause. Okay, cool. I hope you did it. We're back. These should be really quick once you get used to them. The square root of negative 80, well, we can pull a negative 1 out of that. And 80 is 16 times 5. So we'll turn this into square root of 16 times the square root of 5. The square root of negative 1 becomes I. Radical 16 becomes 4. This square root of 5 is not going anywhere. It's okay. It's okay. We can have ugly numbers too sometimes. 4I square root of 5 is our simplified version. And that is it. All right, if you have any questions, do not hesitate to email or message me on Canvas, all right? Thanks a bunch, guys. See ya.